In this video, we are going to be looking at derivation of cosine rule. Now, cosine rule is one of the ways we use to find the sides of a triangle. Now, let's say we've got this triangle. The only thing you need to note is that it's not a right angle triangle. And let's label this triangle ABC. Now, if we know triangle ABC, we need to also label the sides. Now, normally, the side facing an angle, it's always labeled as small letter of the angle. What I mean by that is that this side is facing angle A, so we label side A. So this side facing angle B would be side B, and the side facing angle C will be side C. Does this make sense? Now, basically, what we are trying to find is a relationship between side A, B, and C. Does that make sense? Now, I need you to follow me, and let's do this together. Now, the first thing we want to try to do is to kind of have a right angle in this triangle. So if I have this vertical height, I can label it H. It means that this place is angle 90 and this place is angle 90. Does that make sense? Now, the next thing I want to do also is to label this place. I can label it anything. Let's label it capital D. Can you see? Now, if I have this capital D, I know that from here to here is A. From here to here is A. I can label BD, this place, as X. Now, what that means is that if BD is X, it means that this C would be A minus X. Does that make sense? Now, if I know from here to here to be A, and then I know from here to here to be X, it means from here to here will be the full length, which is A minus X. So A minus X. Does this make sense? Alright, now that we know all the sides required, now the next thing we need to do is to look at this triangle. So we've got two triangles here. We've got triangle A and we've got triangle B. Now, if you look closely, triangle A is a right angle triangle. Triangle B is also a right angle triangle. Another thing you need to notice that H is common to both triangles. So we've got H as the height of triangle A. We've also got H as the height of triangle B. Now, what we are going to do is to relate H together and then equate it. Now, you need to just watch to understand what I mean by that. Now, if I bring out this small triangle here, triangle ABCD, I know this place as H, I know this place as X, I know this place as C. I can use Pythagoras theorem to relate the sides, isn't it? Now, let's do that. Remember Pythagoras theorem. So we have Pythagoras theorem is hypotenuse square equals to opposite square plus adjacent square. I hope you remember this perfectly. So in this case, the side facing the right angle is the hypotenuse. So this is the hypotenuse. If our angle is here, it means this place, the side facing the angle is the opposite. And then this place would become the adjacent. Does that make sense? So I can slot this into this formula. So I should be having C square equals to H square plus X square. So I can make H square the subject of the formula. So X square goes to meet C square. So I should be having C square minus X square equals to H square, which implies that H square equals to C square minus X square. Does this make sense? Alright, so now let's look at the second triangle, which is triangle B. Let me rub up this side so that I can represent it. Now, if I draw triangle B here, I'll be having H, I'll be having B, and then for this place, I'll be having A minus X. Remember, this angle 90, it means the side facing angle 90 is the hypotenuse. If the angle is here, this place will be the opposite, and this place will be the adjacent. Does that make sense? Now, we are going to represent it in this Pythagoras theorem. I will be having hypotenuse square, that is B square, equals to opposite square H square plus adjacent square. Now, this will be A minus X square. Do you understand? So I can make h squared the subject of the formula. So I should be having b squared minus into bracket a minus x squared equals to h squared. Do you understand this? So we have h squared here, we have h squared here. So if h squared equals to c squared minus x squared, and h squared is also equals to b squared minus a minus x squared, it then means that c squared minus x squared is equals to b squared minus a minus x squared. Does that make sense? If I tell you that a equals to b, and then I tell you that a equals to c, it means that b equals to c. It's just common logic. Does that make sense? So we are going to equate these two. C squared minus x squared equals to b squared minus into bracket a minus x squared. Do you understand that? Now let's do that somewhere up so that we can still see it. So I'll be having let me just partition c squared minus x squared equals to b squared minus into bracket a minus x squared. Do you understand this? I hope you got it to this stage. Now let's open these brackets. We'll be having c squared minus x squared equals to b squared minus, if I open this bracket, I'll be having a minus x into bracket a minus x. I hope you agree with this. Now if we open the bracket, we'll be having c squared minus x squared equals to b squared minus a times a will give us a squared, a times minus x will give us minus ax, minus x times a will give us minus ax, then minus x times minus x will give us plus x squared. Do you understand this? We just open the bracket. This times this, this times this, then this times this, and this times this. Does that make sense? So we are having c squared minus x squared equals to b squared minus a squared minus ax is minus 2ax, then we've got plus x squared. Do you understand this? Alright, let me rub off this side so we can have it in a clearer way. So remember, I have c squared minus x squared equals to b squared minus into brackets a squared minus 2ax plus x squared. Open this bracket, so we'll be having c squared minus x squared equals to b squared. If we open the bracket, minus times a squared will be minus a squared, minus times minus 2ax will give us plus 2ax, then minus times plus x squared will give us minus x squared. I hope you know that there's an invisible one here, so it's like we are doing minus 1 times a squared minus 1 times minus 2ax minus 1 times x squared. Does this make sense? Now look, if x squared moves to the other side to meet this x squared here, it will become minus x squared plus x squared, and minus x squared plus x squared is 0. Does that make sense? If I have minus x squared go to the other side and then I collect like them, I'll be having minus x squared plus x squared, and minus x squared plus x squared is 0. So it means I can cancel these two. Do you understand? So I'm left with 6 squared equals to b squared minus a squared plus 2ax. Do you get it? Now there's one more thing we need to do. Now remember, at the beginning of this video I told you that what we are trying to do is to get a relationship for the sides of this triangle, and the sides of this triangle is b, c, and a. So we need to find a way to remove this x. Does that make sense? Now to find x, all I need to do is to bring out this triangle ABD, and the reason for that is that it contains x. So ABD, and so this place is small c, here's x, and here's h. Now if you look closely, this angle here will be angle B, capital B. Does that make sense? Now I can find the relationship between c and x. The reason for that is that c is a side in a triangle and x is what I'm trying to replace here. Does this make sense? Now we can actually use SOHCAHTOA. I hope you remember SOHCAHTOA. Yes, so C is the hypotenuse because it's facing angle 90, and then if this is the angle we are considering, it means H is the opposite and S is the adjacent. Remember, we are trying to relate C and X, so that's hypotenuse and adjacent, so we are going to be picking cos. So we'll be having cos B, because B is the angle, equals to adjacent over hypotenuse, and the adjacent is X, hypotenuse is C. Does this make sense? Now I can make X the subject of the formula, so we'll be having X equals to C cos B. All I just did was to cross multiply. X times 1 is X, equals to cos B times C is C cos B. Now I'm going to put this into this equation. So anywhere I see X, I call it C cos B. Does that make sense? So we'll be having C square equals to B square minus A square plus 2A into brackets C cos B. Do you understand this? Now we can open this bracket, and then we'll be having C square equals to B square minus A square plus 2AC cos B. And here we have one of the cosine rule, so you can understand it better. I'm going to do a little bit of a rearrangement. Let me rub up the right hand side. Now normally, because I've got AC in this part, it means that normally in this formula, B square should be the subject of the formula, not C square. So if I do some rearrangement and take A square and 2AC cos B to the other side, I'll be having something like this. B square equals to A square plus C square minus 2AC cos B. And here's the first cosine formula. Do you understand? Now also we can, in this same vein, find C and A. So watch closely. So for A, we'll be having A square equals to B square plus C square minus 2BC cos A. Can you see what is happening here? Now when we have B square, we'll be having A square C square minus 2AC cos B. Now when we have A square, we'll be having B square plus C square minus 2BC cos A. Does that make sense? Now what do we have when we have C square? Now with C square, we are left with A and B as the other sides. So we'll be putting A square plus B square minus 2AB, then cos C. So we have cos C. Do you understand? Now these are the three formulas that represent the cosine rule. So all we just did is so that you understand how we get the formula. But most time when you are giving in examination, you are expected to just give the formula without giving the derivation. So don't forget, B square equals to the other sides, A square plus C square minus 2AC cos what you have before the equal to sign. Does this make sense? Now the last thing I need to do in this video is to make you understand when to use cosine rule. So when do we use cosine rule? So let me write it here. When do we use cosine rule? So I'm going to put cosine rule kind of when. So when do we use cosine rule? So first we use cosine rule when we know three sides of the triangle and we are told to find an angle. So we know three sides, B, A, C, and we are told to find the angle B. Does that make sense? The second situation when we use cosine rule is when we know two sides of the triangle and we know an angle, then we are told to find the third side. Does this make sense? Here we are told to find the angle. Here we are told to find the third side. So anytime we have these two situations, we can use cosine rule. So the first one is, we know three sides and we are told to find an angle. We know two sides and an angle and we are told to find the third side. Do you understand this?